Okay, so again welcome back. Today's agenda is discussing problem 15 of JAM 2025 paper. So let's delve in. Here we have a function f that is mapping from 0 1 open to R and is said to have property I if for any basically x1 less than x2 lying in the interval 0 1 open, and for any c between fx1 and fx2 there exists y belonging to x1 x2 such that f of y is c. So in a fancy way they are saying that if you take this 0 1 set both excluded, take any x1 x2, okay, and this will be some f of x1, this will be some f of x2. So you can think of these two values. Now you take any value in between, say this value. So this value, say it is c. So there will be a point y which is lying in between x1 x2 for which f of y equals to c. So this is basically the intermediate value property, right? now the thing is, you have two statements involving the property I, that is regarding g. It is saying that g mapping from 0 1 to R satisfies property I, then this is necessarily continuous. Second statement is, if h 0 1 to R is differentiable, then h prime necessarily satisfies property I. So we will see which one is correct, and because all the four options, they are regarding four possibilities of these two statements, right? So what are the concepts and notions that are required? So property I is the intermediate value property, as I said, and it is also called as the Darboux property, right? So this term is also very much used and taught in real analysis. So this Darboux property is very closely related with intermediate value property, so that we will see. And it is not exactly the intermediate value property, but very much connected to it or utilizes it. So if has I, this property I implies if x1 x2 contains every value between f of x1 and f of x2. So that's the key notion. All the values in between these two real numbers are contained inside the set f of x1 x2. Now here the first statement says if g satisfies this property, then g is necessarily continuous. Well, this is not always true. Why? Because a function can have the intermediate value property and still it can be discontinuous. So this is very important notion. So and this counter example here is again very interesting. So why it is interesting? So here if you see the sine function, it is here defined for 0 1, that is there, and in half there is a problem. So in half it is defined as 0, and outside half, this you can see x minus half can be arbitrarily small both in the positive side and negative side. So that sort of behaves like the function sine 1 over x. So here there are wild oscillations, and that oscillation will be in between this sine function. It is taking values from -1 to 1. So all values should be obtained in this interval by this function gx, right? So on any interval not containing half, g is continuous. That is true, and that also implies intermediate value property holds. On any interval containing half, the oscillation near half attains values arbitrarily close to every number in -1 1, right? That is also there by the property of sine. So you can basically put any c belonging to open 0 1 equal to sine 1 by x minus half, and you can obtain a solution, a legit solution. So that here gives us the property IVT, or the property I, even on the interval containing half, where the function gx is not necessarily continuous. Hence, option I or statement I is false. So what about the next statement? The next statement was, if h is differentiable and h prime will also necessarily satisfy property I. Now this again is exactly the Darboux theorem. If you are not aware of it, kindly go through the statement. It is exactly the statement that if h is differentiable, then h prime necessarily follows the intermediate value theorem, and it can be intuitively proved. Well, the proof is little bit involved, but here you can prove it intuitively using the notion of derivatives. And if it is differentiable, that necessarily means that this limit hx plus k minus hx by k, this limit should go to h prime x for any x in 0, 1. So that means this should be satisfied, and in contrary, if h prime does not satisfy this property I, then this should not be differentiable everywhere. That is what you can also prove. However, this is actually the Darboux theorem. So from there we can actually conclude that statement 2 is correct. I am not now going into the exact details of Darboux theorem. It is better if you have a look at the result, and that will be much more nourishing and also maybe conceptually enriching, because you might get to learn many things from out of that. So this is the thing, and that automatically implies option B is the correct answer, where statement 1 is incorrect and statement 2 is correct. So that is it. Hare Krishna. See you in the next video.